So, if you're on Facebook at all or reading anything on the internet, you know right now there's this big push to being chemical free. Hate to tell you, there is no such thing as chemical free because everything is made out of compounds. Now, you can talk about additive free and get into a lot of debates about that, but don't believe anything is 100% chemical free because everything is made out of compounds. So all matter, all stuff, anything you can see, you can touch, you can feel, you can taste, you can smell, it's made out of chemicals. Now, chemicals are not necessarily bad. Now, that term chemicals sometimes gets a bad rap. Maybe we should use the term compounds. Everything's made out of compounds, but that's all a chemical is. So there are no chemical-free foods or products. And all of those compounds, each of them can be good or they can be bad. Um, and it's not necessarily that that compound itself is good or bad. It might be in the amount that is taken in, or maybe it's in the type of exposure. So everything has a risk and everything has a benefit. Example for you, nitroglycerin. You know what nitroglycerin's used for? Well, back in the day, it was used as a heart medicine. So take a small amount of nitroglycerin and it helps control your heart. But if you have a larger amount of nitroglycerin, well, that can be used as an explosive. And if you get bored sometimes, look up at the story of Alfred Nobel. He's the one that came up with the Nobel Peace Prize, um, the mass merchant of death. He helped invent nitroglycerin. And then he had to later take it as a heart medicine. And it's an interesting story. So everything, like I said, has a risk and a benefit. We'll look at more of those examples on the next slide. Now, someone who wrote a lot about this or is kind of deals with this idea that things can be good or bad depending on how much is a guy by the name of Paracelsus. Now, his real name was Philippus Aureolus. There we go. Whew, that was hard for me. And he was a soldier, and he was Swiss or German, somewhere in that area, in the early 1500s. Now, as a child, his dad actually taught some chemistry, so he had absorbed a lot of this chemistry knowledge. He was in an area that dealt a lot with mining and smelting metals to be able to remove the metal from the ore. So he dealt a lot with what's called metallurgy. So he knows some about these different metals and these compounds that not necessarily everyone would know about. Now he's famous for saying poison is in everything and no thing is without poison. The dosage makes it either a poison or a remedy. He had this idea that what was known to be poisonous in large quantities, maybe in small quantities, could actually be curative, could actually help you. Now, he did a lot of traveling. He ended up learning about medicine and was a military surgeon for a while. He gained a lot of his medical information from locals, which that was kind of against what was normally taught. Like normally a doctor goes to college and they use that information they learned at college. Well, he didn't do that. He went to college, he learned that knowledge, but he actually used the knowledge that he gained from locals. I have another quote here for you. I have not been ashamed to learn from tramps, butchers, and barbers. I have not been ashamed to learn from tramps, butchers, and barbers. So he took people that were actually helping the sick in these rural areas, especially, and he was trying to gain knowledge from them. He promoted minerals and metals in a diet. He felt that humans had to have a certain balance in their bodies. Um, and talked a lot about using different things, different chemicals to cure. He did kind of butt heads with the medical industry at that point in time. He was actually called the Luther of medicine. But he has even though he's a controversial guy, I like a lot of these ideas that the poison is in the dosage. Okay, so here we are at The poison is in the dosage. The idea that every beneficial thing also has risk, whether that be natural or man-made. So I have a few examples down the bottom. We're going to do what are called some risk-benefit analysis. We're just going to look to see for an individual item, what can be good and what can be bad. How much risk is there? Risk is just the acceptability, or I'm sorry, safety is the acceptability of risk. So let's look at some examples. The first one I have listed is caffeine. Now, caffeine does tend to be my drug of choice. I like a little caffeine jolt. I don't drink pop, but sweet tea, man, that's some good stuff. Caffeine can provide a jolt to your nervous system, can help stay awake, help make you more alert. It can also be lethal, though. Those monster drinks that you drink, they are not the best for you. Caffeine actually has what's called an LD50, a lethal dose for 50% of a population of about 70 cups of coffee. Okay, if you were to sit down and drink 70 cups of coffee without getting up or anything, just all at one sitting, you would have a 50% chance of dying. Isn't that crazy? Now, there have been some cases recently where people who did take a lot of monster drinks were having some issues. Now, that's just the LD50, the poisonous side. It's not necessarily looking to see the effect of that caffeine on your body. So maybe you have some heart issues and you can't handle that extra jolt to your nervous system. Your heart can't handle it, maybe. So it's not looking at everything, but that's just one part of it. The next one I have listed is acetylsalicylic acid. Yeah, it's just kind of fun to say. Good old aspirin. Um, Aspirin's one of the most widely used medicines today. We average about 80 tablets per person per year. It can help relieve headaches. Um, so it's an analgesic, help relieves pain. It can help relieve fevers. It's an antipyretic. It's an anti-inflammatory. It can relieve inflammation. It also decreases blood clots. Well, that could be really, really good. So if someone thinks they're having a heart attack or a stroke, usually what they'll do is tell them to first, but if they can't receive medical attention right away, is to take an aspirin because that's going to reduce blood clots. But let's say that you're someone that maybe a diabetic. Diabetics have hard times with blood clotting anyway. So if you take a lot of aspirin, my husband is on an aspirin regimen along with several other medicines to uh, reduce cholesterol and help his heart. He actually had some stents put in, so he's on an anti-platelet type medicine. His blood doesn't like to clot, so he bruises really, really easily. If he gets a little cut, he bleeds a lot. Um, so the same aspirin that could be really beneficial could also be something that isn't necessarily the best for a person. BPA is listed last on this one. Oh, I'm sorry, I forgot my water. So y'all know that you need to have water. You need to be drinking 8 cups of water at least every single day. Help flush out your system. Well, if you drink too much water, that can also be bad for you. They have something called water intoxication, where you actually get drunk on water. This happens a lot of times with marathon runners, that after a marathon, they're ingesting large, large amounts of water. Their electrolytic balance in their bodies have been thrown off because of the exercise that they have done, and they actually start acting drunk, but all they've had is water. So that's kind of an interesting little area to look at. Um, there was a case a few years ago, I think it was back in 2007. It was called Hold Your Wii for a Wii. I know, funny name. But that's when the Wii gaming system came out. And so they actually had this contest to see who could drink the most water without peeing. And then whoever could do that would win this Wii system. Um, the gal that is often discussed did not win the system, but she ended up dying because of drinking too much water. Now, the last one, we'll finally get to it, is BPA. Now, BPA is an additive that's often added to polycarbonate plastics and epoxy resins. So it was used in water bottles, infant bottles, liners for cans. It would help increase the resistance to shatter, so it would be less likely to break. But then oh, and also the other good thing is that it didn't alter the taste of food or the consistency. So it didn't seem to really do anything. But what they found is that this particular compound could actually pass from the containers into the food or drink that it was in there and then into the body, and then it would build up in your body, and that was a bad thing to have happen. So the BPA has been removed from a lot of your plastics today. So we can be exposed to different chemicals, different compounds from natural sources, so say coffee, from things that are synthetic or semi-synthetic, as we'll learn, such as aspirin, or it can come from our environment, such as just drinking water. We can deliberately ingest things, or we can have unintentional ingestion. So BPA would be an example of that, where it's in our containers, but then it is somehow moved to our food source and we ingest it that way. So we have a lot of exposure to different chemicals and compounds in our life. This table just shows you a few. So the little question that I have for you right now is over-the-counter allergy medicine safe? True or false? Yes or no? What do you think? Well, this one, I don't know if it necessarily has a complete right or wrong answer. This class is designed to make you think a little more, so that's what I'm trying to do with this particular question. We generally regard over-the-counter allergy medicine to be safe. It's very helpful. When your nose is all stuffed up and your eyes are red and itchy and you just can't think straight, allergy medicine is an amazing thing. But with anything, safety is the acceptability of risk. There are risks associated with any type of medicine that you take, including allergy medicine. So we can say yes, generally accepted as safe, but then again, nothing is completely safe under every condition. So, trick question.